Hi, I'm Rico with Maker Code, and in today's episode, we are going to talk about my Unitree Go2 and attempting to map with it. Why mapping? Well, that is kind of the first step I want to accomplish in my overarching goal. And what is my overarching goal? To basically get my robots to be as smart as this guy. This is my Roborock Q-Revo Flow 2. It's got the mopping action. It's got a LiDAR. It's got a camera with AI detection. It drives around. I can remote control it. And it cleans my house. So, I would like my Unitree Go2. I would like my R2D2. And even my Robo Scout to be able to do this. And so the first step in all of this. So the first step in all of this is mapping. When you first run this guy, the first thing it does after you connect it to Wi-Fi is map out your entire house. And how does it do that? You hit start mapping and it just starts driving, and it drives all around your house. It looks for everything. It goes to every wall, every door, everywhere it could possibly drive to, and just keeps on mapping. It looks for walls, it looks for doors, it looks for thresholds. It then will segmentate out the house and say, this looked like it was a bedroom, this looked like it was a living room, this looked like it was a kitchen. So that is what I want to do first. I want to be able to at least do step one. Turn on a robot, whether it's R2D2, my Robo Scout, or Unitree Go2, and say, go map. And I'm kind of at that point right now. It kind of works. I've tried this out a couple times, trying it now in my garage, so it's even more limited on what it could see, more limited on where it can drive around into, but it seemed like a more controlled environment for this kind of testing. So I have found through the different channels for Unitree Go2, the unofficial ROS2 SDK. And what does that mean? Normally when you buy Unitree Go2, you need to buy the EDU version if you want to do the real hacking with this thing. This unofficial ROS2 SDK allows you to run a ROS2 environment, feeding in all the sensor data from the Unitree Go2 wirelessly. You can do it wired, a little more hacking involved, or wirelessly. So same way that you use the controls on your phone, that is streamed through the network. This captures that information through the network, passes it into a ROS2 environment, then it starts outputting ROS2 topics, just like a ROS2 environment. All wirelessly, no modifications required on the Go2, but this will allow me to now have LiDAR information, camera information, odometry information, teleop, all set up already. The goal again, have R2D2 and RoboScout have those things, but I don't have those right now. I will. We'll talk about that later. But for now, I just need that to work. Can I get, if I were to have a LiDAR, at the very least LiDAR, and camera, because it does have camera, can I get a map built in my house? And I found it works. It doesn't work, it works. We'll go through it. So first thing let's do is let's get this environment set up on your computer. Very simple. You're going to clone the GitHub repository. So let me pull up the GitHub repository. Hold on one second. Let's see here. We want to now open this. And Let's make sure you can see it. Yes. Okay. So on the GitHub repository at the top here, if we go to the top, what you're going to do is just clone this directory. So I'm assuming you're at least somewhat technical as far as when I say clone a GitHub repository. You're going to clone this GitHub repository. It'll then be on your computer. I also cloned this to my Jetson Orin Nano. Again, not sitting on my desk, wirelessly connected on the same network. But again, all it needs to do is have the Unitree Go2 be able to be on the same network as the Jetson Orin or my laptop, wherever I clone it. And then when it starts seeing the Unitree Go2 information, it'll start to display the information in the RViz environment. Okay, so I have already cloned that, and that is in this directory. So they give you some instructions. We'll go through that real quick. If we were to scroll down, and basically you are just going to build this like any other ROS2 environment. I'm not a huge fan of ROS, but these are the instructions. Pretty simple. So you go through and you're going to record all that. Or sorry, you're going to do all this. I did it, again, this is running on a Jetson Orin, so it's going to use Humble. And I've already done this pip install. I've already installed all the dependencies. And then I did this install and Culkin build. So now I have a working environment in my Jetson. And again, you don't have to use a Jetson. I also have it working on my Mac. It's just so that I can start playing with other things that's on there. Okay, so now let's look at one other thing in the repository that I forgot. And that is, if we go to the top of this, there is under the Go2 Robot SDK, these launch files. So there are a couple different launch files, and they all depend on what you want to do. So if you're just going to play around with it, the WebRTC web is more than enough. It just launches enough to get you up and looking at things. Same thing with the robot launch. That one, again, just a general environment that you're going to use. Then if you're going to do mapping, this is more optimized launch file for mapping. So all the topics and all that are configured with the LiDAR and the camera and everything so that you can start saving a map using RViz and the plugin. We'll go over all that. And then you could use navigation to say, okay, I'm going to set a waypoint now, and let's move to that point on the map after I've already recorded a map. So I'm going to use this mapping.launch.py. The only important thing that you have to remember when you are launching these files, we'll go back to the beginning real quick because I do just load this as a script file for me because there are 3 commands and I don't feel like typing them. But you are going to source. This is normal for ROS2. So again, all you're doing is basically saying take in this repo and all its dependencies. Then you're going to set the robot IP and whatever your IP is for your robot. I have modified my my IP address just because I want it on a separate network from the rest of my house. So it has its own IP starting with 1010. And then we're going to say WebRTC, and this is the wireless connection. They have the other one, Cyclone DDS or whatever, yeah, here, that you could set it to. That is if you hooked up an Ethernet cable to your Unitree Go2. They do have an Ethernet port on it. You pop that cap off, and then you could plug in Ethernet. You get a little bit better streaming, but you're tethered to a cord. I don't want to deal with that right now. My Roborock does not have that, so I don't want to deal with that. Okay, and then you run the launch file. And again, the generic one is robot. I'm going to do mapping instead. So we'll go over to my Unitree Go2, and I will be, if you look here, I've made a couple different scripts. all these scripts are basically just going to say those commands. So I'm going to say mapping, and you can see I'm just loading those commands. So nothing special again, exactly how the instructions had it. Okay, so now that I have this set up, I'm going to just run startup and mapping.sh. Okay, so now this is starting up an RViz environment. You can also see it a little bit larger here if you wanted. And then I have the controller that I will be using also to control the robot. So I'm going to turn on point cloud, and I hope that this is on the same network. Let me see. It is good, but I don't see any information. Why? The robot model has an error. What is the error? All those errors. Well, I haven't run this in a couple days, so what could these errors mean? Okay, figured out all the little details. The Wi-Fi did not want to work in the garage. So I got that working now. Okay, so let's see here now. We need to start this process. So let's start it up. And when this starts, we will get this RViz window. And we will see here the red dots are the laser scan. So we can turn that off. The map is there, so you can see the map. And the point cloud, which you're used to seeing in the app, is right there. Okay, so as you can see in this image here, we have a wall, and we have the couch that it's looking at right now. So if I were to turn, the robot will start to, oops, I'm doing this kind of blindly. Okay, so there is a narrow gap that it sees here. And if I keep turning around, let's keep turning. There's a table with some stuff and some more stuff, but basically it is in a square. So there is not a lot to see in this square, but it does see it in there. Okay, so we have something at least, right? I've kind of looked all around, and that's what you see. Okay, so now let's turn on this plugin, panels. So we have the SLAM toolbox, and you'll see here this option for save map and serialize map. Save map, I guess, is the older format. Serialize map is the newer format. I just put it in both. So I'm going to call this YouTube map and YouTube serialize map. And what I'm going to do is just walk around, and then I'm going to click save map and serialize map. And those two maps will be stored in my RViz environment in the project folder so that I can go back and use these maps later. So don't hit save map yet. Let's start walking around. So we're going to do this FPV style. There's my cat. And you will lose it in the camera view. But I'm now going to, Look at my cat. He's not even budging. He's just sitting there. Hi, bud. Thank you. And let's keep walking into my little breakfast nook. Into what? Oh, there's a blanket sitting there. Someone took it off the ground, I guess. Oh, and I just walked into that bowl. And what I'm trying to do is on the map, just start seeing a little bit more. So as I go around, I'm going to see that this is kind of a rectangle. And I'm just looking around. And in the map, it's not really updating well. Not really sure what's going on there. Let's see, is it? Yeah, that's normal. Okay. So we will just keep turning. Oh, hitting the wall. There, turn. I don't remember which one strife is versus turn. This one's turn. Okay, and then we walk back. And I have a feeling that I lost. No, because I have video feed, which is strange. I don't know why the map isn't really updating. I do know I have to play with the settings here to make it see more, but I'll just keep walking along. I'm not 100% sure why. I have to stay away from my animals because I don't want them to get hit. Let's see, why isn't point cloud working? I'm not really sure. I haven't seen that problem before. I'm wondering if it's still my Wi-Fi issue. Maybe it's jumping Wi-Fi access points. Looks like I gotta get one in the garage if I'm really gonna do testing in the garage. But let's just hit save and serialize. And now when I go into that folder, I will have a map called, where are you? UT map. Yeah, so UT map and UT serial. So the two maps are here. And there's actually a total of 4 files. So there's going to be an image, a map, and a map. And I can already tell there's an issue because the image that it's showing is just that, no point cloud. So let's figure out what's going on with this point cloud. When I've had this issue before, I just start it over. Let's start it over. Close this out. Yes. Because I don't think it's a Wi-Fi issue because I can see it through Wi-Fi. Okay, so we're starting over again. Cat is sitting next to it. We have our guy here, our point cloud is not visible. What's going on with this point cloud? There it goes. Okay. And then we'll pull in this SLAM toolbox again. And let's start walking around. There is a setting that sometimes I play with to let me have a longer point cloud so I can add more points in the output, but I also find it's not that great, so no big deal. Now, one of the things I have to think about when I'm walking is to not walk too fast, and I have like a little simulation on why that is, but the slower I walk, the better for this mapping. When I'm with my Roborock and it's driving around, it's doing it at a pretty good speed. So it definitely sees what it needs to see. Okay, so I'm walking in. Looks like I'm stepping on the bowl. Again, this is a slower feed than what's actually happening in real life. But you can see here in this model now that I've got this hallway / galley style kitchen. So let's rotate around. And now it sees my little breakfast nook area. And we can even get a little bit more of that breakfast nook area so it kind of sees all the wall. So you can see in this picture, right, we're looking at the tabletop right here and the walls here. So it's seeing everything. And then we'll come back out here. I think I cleared it. Turn. Again, there's a small delay in the video feed, so I can't just freely walk. And we'll come back out. And you'll see that the point cloud already disappeared for where the kitchen was. But again, it's there. It just didn't display it anymore. Okay, so let's turn a little bit so you can get a rectangular. Yes. 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 Okay. We're going to call this one YouTube Map 1 and YouTube Serial Map 1. Now I'm going to hit Save and Serialize Map. Okay. And again, if we look now in that directory, we'll see the 1. And so you'll see now that this guy is a little bit larger. And again, what it's showing you is these dots. So if I were to turn off point cloud, it's showing you all this stuff that it found. So it saw this, and then this little area. But if you turn on point cloud, you get to see a little bit more in depth. So this is underneath the table. So it's got a little bit of height, but not a lot of height. And then the little passageway to go into the kitchen, and then the kitchen was over here, and the point cloud has already disappeared, but it was there. Okay, so now we have a saved map. We did this saved map and the serialized map, and now we can stop RViz, close, and we can cancel out of this one. And now I'm going to start the launch file that is, instead of the navigation or the mapping, I'm going to start the navigation one. So if I look at startup and I do nav, you'll see here that all I'm doing is I'm starting the navigation one, but I'm also giving it a map that I've done, right? So I have to change this map that I saved. The map name now is called, before it was called mapsave.yaml, and now I have ytmap1.yaml. So let's change this file real quick. Startup nav.sh, and we are going to change this to say ytmap_1. So now it's going to use the map we just created. in this startup. So now we'll do startup nav, and it's starting it up, and it's going to also load that map that we just created so it doesn't have to recreate it. And with the SLAM toolbox now, so you see the map that we had created before. And now if I load the panel for the navigation, and I load, and here now it's looking for where it's located. So it's trying to determine if it knows where it's located based off the map I gave it. And you can see the map is not very great. It didn't, the kitchen, if that's the kitchen here, right? It does show the outskirts, but this breakfast nook area is completely lost. And then this area where the kitchen is there. If you look at where that table is, and then there's like a wall in between there, it's not quite what you expect it to be. But the navigation is saying that localization and navigation are there. So if I were to just set a point, so I'll set it to be a safe spot like right here. I will say, let's put a nav to goal, and I will set it to here, and then it does this weird line to show you which direction you want to point. And then it will start to try to navigate to that point. All right, and so now what's going to happen normally is it just does a 360-degree or less turn. So right now it's trying to figure out what to do. It's turning, and then aborted. And this is what I typically get. And I can only assume that's just because this map isn't great. I didn't have enough information to navigate to that point, or couldn't find a safe path to that point. I'm not 100% sure, but I mean, I could even choose another spot that is really close. So we'll just say right here. And as I expect it to do, it doesn't really matter. I'll even make it turn that way. Is it going to be able to get to that point? So again, it's just going to rotate. Again, you can see the feedback here is going. The thing, and let's see, hopefully it will walk over to that point, but no, we just keep rotating, and then eventually it aborts. So I'm not an expert at this yet, so this is what I'm trying to figure out, and this is where I'm at right now. I've created the map is saved through RViz, and now I'm trying to utilize that map and say, go to a position on that map. And again, I think the reason why I'm not getting great results is because the map isn't great that I saved. So why? Why isn't this map good? So then the beauty of AI, I asked Claude, what's going on here? Why can't I get this mapping to work? And what it told me basically is that my map is not great. And the reason why is more in the fact that I am utilizing a LiDAR that wasn't intended for mapping. This LiDAR was intended for obstacle avoidance. And navigation is more on the side with this LiDAR of just getting through obstacles and not actually saying, I know I'm here and I will get you here. Well, that video got way too long, so I decided to break this up into 3 parts. So like and subscribe and wait for the second part, which will go over LiDAR and all the different sensors and how I fix this problem. And then in the third part will be about depth cameras and how I will fix it using also depth cameras and LiDARs.